So this will be the third video for our 6D fractions with radicals. And we'll begin here with these examples. So these get a little more complicated. And here's some instructions. We want to always reduce the fraction if possible and simplify the radicals again if possible before you check the denominator to see if there's if there's a radical in it and if it needs to be rationalized. So before rationalizing, rewrite the denominator as a power if possible. For example, write 49 as 7 squared or 8 as 2 to the third. All right, so here we have the cube root of 8x to the fourth over 9. I don't see that it will reduce, but when I look at the numerator, I know the cube root of 8. The cube root of 8 is going to be 2. So I could separate this into the cube root of 8 and then x cubed and then be left with the cube root of x. And then we're going to separate. Remember, I said I want you to rewrite. We don't know the cube root of 9, but we're going to think in terms of the 9 is actually 3 squared. All right, so the cube root of 8, that's 2, and that's an x. And then I'm left with the cube root of x. And in the denominator now, I've got the cube root of 3 squared. So I do have a radical in the denominator that can't be simplified or reduced. So I need to rationalize it. So the question is, how many more 3's do I need to make it a perfect cube root? Well, I have 2, so I really only need 1 more 3. So clever 1 multiplied by the same thing, top and bottom, and that's going to give me then 2x, the cube root of x times 3, so that's 3x. And then this is going to be the cube root of 3 to the third, and the cube root of 3 to the third is 3. I ran out of room there to show that extra step. All right, so example H. Again, this time I see that I cannot reduce it, but this is a square root, so I can actually simplify both of these. So I have the square root of x squared, which is x. And in the denominator, I have the square root, and I'm going to break it up into perfect, y to the fourth, and y. So that means now in the denominator, I have the square root of y to the fourth, which is y to the second, and then I'm left with radical y. All right, so I'm finished simplifying and reducing, and I see that I do have a radical left in the denominator. Now, it is a square root, so that means I just need to multiply by itself. Clever 1 there. And this is going to give me then x radical y divided by y squared, and then square root of y times square root of y is y. So that's going to be y squared times another y is going to give me y to the third power for that answer. All right, so let's do one last example here. Again, I will separate this into the fourth root of, let's see, 81. That is perfect, isn't it? Perfect fourth power, because this time the index is a 4, and 3 to the fourth is 81. So I'm going to put an 81 here, and then a 8 to the ninth. If I want a perfect fourth, that's going to be 8 of them here, with 1 left over to the side. And then down here, I'm going to have the fourth root of 8, which I'm going to write it as a power 2 to the third power. So that is then going to give us fourth root of 81, that is 3. And then the fourth root of 8 to the 8th is a squared, the fourth root of a. And then we still have down here the fourth root of 2 to the third. All right, so I'm still stuck with this radical in the denominator, so I need to make it perfect. My index is 4, and I have 2 to the third power. So how many more 2's do I need? That's right, just 1 more. So I have the fourth root of 2, clever 1, so put that on top as well. And when I multiply that, I'm going to end up with 3a squared, fourth root of 8 times 2, so that's 2a, all over, and this is going to become the fourth root of 2 to the fourth, which is 2 for my answer. All right, scary things, but I want you to now try these. So you give your best effort. I don't care how messed up it is. Unless you try it, you're not going to know what your questions are. So next class, we're looking for it. Try these.